Welcome to this video that deals with the lab orientation estimation using smartphone sensors. This is one of my favorite labs, and that's because you get to use your own smartphone, something like this, and the sensors within it, something that you carry with you every day. And you use these sensors to estimate orientation on the phone. This is something that is done internally in the phone as well. That gives you the possibility to compare your results with your implementation to what Google has managed to do in their implementation. In doing so, you will address several of the practical aspects there are of sensor fusion, deal with implementation of the extended Kalman filter and outliers. The problem that you're about to solve in this lab is to connect your phone to the computer and then stream live from the phone the inertial measurements from it. That is the accelerometer measurements, the gyroscope measurements, and the magnetometer measurements. And you will use that to estimate the orientation of the phone and compete with orientation estimate that is built in the phone. You get to do this in real time, so you get to real time implement the filter, and you have to deal with outliers, that's something that you will definitely experience throughout the lab. The lab takes you through 8 different steps. In the first, you're connecting your phone to your computer. In this way, you get a live stream of measurements from your phone to the computer that you can process there. The second step is a common and very important step in all filtering applications. So you need to get to know your data. What does the data tell you about the problem that you're trying to solve? What kind of problems are there with the data? Are there artifacts or other problems that you need to deal with? And can you use the data in complementary ways? For example, if you have several sources. Once you know the data, it's time to start implementing an extended Kalman filter. And in the first step, you will implement the time update step, in which you use a gyroscope to predict how the phone is changing its orientation throughout time. You'll notice that it's difficult to get a match between your estimate and the estimate that's provided by the phone itself. So therefore, we'll first, in the next 2 steps, introduce accelerometer measurements and make that a indication of down, and hence force your orientation estimate to provide the correct down direction. And as there are always going to be outliers, as you'll see throughout the lab, you need to implement a way to avoid that impacting your estimate too much. Still, you have a different time to find the true forward of the estimate, so we introduce the magnetometer to do this. Once again, you have to deal with outliers. In the last step, you will see what kind of impact does the gyroscope measurements have on the estimate. You use them in your time update step, but what happens if you remove them? The examination of this lab is to present a working solution of the online orientation estimation problem to your lab assistant. So you will need to provide a working solution and show that it addresses aspects that are highlighted in the lab instructions. To complete the lab, you will have a number of measurements available from the phone in your computer live. That will be the accelerometer measurements that provides acceleration if the phone is not moving around. That will be the gravity that you can use to find a down direction. The gyroscope measurements which provide the relative change of orientation throughout time, and the magnetometer. The measurement from the magnetometer provides a north direction that you can use to align your orientation estimate. Note, the magnetometer is not strictly speaking an inertial measurement, but it is most often included in inertial measurement units that you buy. Some of the most important components that you will deal with throughout the lab works is the quaternions. That is a representation of orientation in 3D. You'll use that as your state, and you'll have to work with that throughout the lab. You also have to design and implement an extended Kalman filter. So not using any framework this time, you will implement it more or less from scratch. And finally, you'll have to deal with outliers and how to mitigate them. To get started and get the measurements to your computer, there are 6 steps to be performed. the first thing we have to do is to download the Sensor Fusion app. You can do it through the normal Play Store from Google. If you search for Sensor Fusion app, one of the first listed apps should be the Sensor Fusion app from Linköping University. It's a blue icon with a horseshoe magnet on it. Click on it to install it. Wait for a while. And then we can open it. We need to allow access to device location and to the file storage. That's to be able to display position measurements and as well save data to file. We can click select sensor and, for example, look at the gyroscope measurements. So now I'm rotating my phone in two different directions, and you see how that is then reflected in the measurements. Please do that for the measurements that we're going to use in this lab to get a bit of a feeling for what they are actually doing and what you can observe in the measurements. So you can also look at the sensor list to see a lot of sensors that's provided by the phone. Some of them are real, like the accelerometer or the gyroscope, whereas others, such as the orientation, for example, is just a virtual sensor that's used by the phone to give the developers of apps the possibility to use high-level information. I have already connected my smartphone and the computer to the same local network. So let's go right ahead and see what IP address I should feed into the app. IP. I'll see the local network there. And this number, IP address here, should match the one here. Now, we're all set to start collecting data and analyze it in real time. So let's start by actually going to the log data here. You see that we're going to stream, and we have a target address here that matches the thing that we got from show IP. You select the sensors that we are interested in, the accelerometer, the gyroscope, the magnetic field sensor, and the orientation for reference. Now, important, we start the collection in MATLAB first. Starts up a server that we should connect to from the phone. I choose here to use the filter template that you are given, and I extract the estimate and the measurements. Hit enter, you see it lists the IP address once again, and it matches the thing here. And I hit start here. I now get two different orientation illustrations. One that is based on Google's estimate, that's the orientation thing. And well, you have just to trust me that it's actually correct. And I get my own estimate. And as this is actually the implementation of the filter templates that you're given, there's no code for estimating the orientation yet. So you'll have to implement that, and you should see the two illustrations move similarly. Okay, so once we are this far, we could also start to turn on and off sensors that we are interested in seeing what kind of effect they have on the estimate. So for example, we could turn off the accelerometer for a while, and then you should see how that affects your own estimate. Google is still using all of the sensors for its estimates. You could also do the same thing for the gyroscope and magnetic field measurements. So once we have all the data that we want, then we press stop. Streaming stops on the phone, and MATLAB scripts could soon recognize that. Okay, there we go. Now we can look at the data that we got out. Start with, let's look at mesh. That's a struct with the time of all the measurements that we got from the accelerometer, gyroscope, magnetic field, and orientation. We could plot the accelerometer, for example. Let's plot it with the correct time. Like this, and let's put a new figure for this. And there you see the measurements. you see that there is a break between like 50 and 60 seconds, and that's due to me turning off the sensor. We could do the same for the gyroscope, get something similar, and for the magnetic field, you see it here. You can also plot the orientation, which is then the estimate in quaternions. So you get the 4 quaternion components here. Let's also look at the estimate that you get out. It's kind of boring at the moment, but we at least see the structure. It has well the struct. It has the time of each estimate, the state x, and the uncertainty p. And right now, it's very boring. So let's plot the estimate. And yet another figure. And you see there is actually a line at 1 and 3 at 0 because our estimate is yet to be implemented, and we get the unit quaternion that is indicating no rotation whatsoever. The problem that people sometimes have when they try to do this lab is that they cannot get any data from the phone to MATLAB. Let's see what can actually go wrong. So one important thing is to start the MATLAB script before you start the phone. So let's see what happens if you don't. You immediately more or less get an I/O error from the phone stating that it cannot connect to the server. This is one of the typical reasons for not getting things to work. So make sure that you start the MATLAB service before you start the collection on your phone. Another common error is that you set the incorrect IP number. So let's see if I just change the IP number here to something that's incorrect. I start up the MATLAB script. And start my collection. Now there's no match between this IP address and this IP address. We quite soon get an error from the phone stating that it's an I/O error, and in a while here the MATLAB script gives up as well and gives you an indication that something went wrong. Of course, to fix this, just set your IP address correctly. Another error that can occur is that you're not connecting the phone and the computer to the same network, which makes it impossible for the phone to address the computer directly. Then you get the same kind of error message as you would get if you have the wrong IP address, because the IP address is basically not found from the app side. Another common error is that the computer has a firewall that blocks port 3400. That is the port that's used by the app to communicate with the computer. So if it's blocked, you won't be able to send any data to the computer. To solve this, simply open up the port in the firewall. Some closing remarks. The goals of this lab work is to stream data from your smartphone and estimate its orientation. The main objectives from a learning point of view is to experience working with real data and handle imperfections and disturbances that might occur in measurements. You should also gain understanding of inertial and magnetic measurements and their complementary properties for this problem. You should use quaternions to represent orientation, and you should design and code an extended Kalman filter. Examination is the presentation of a working solution, and we assume this to take about 16 hours. Good luck and have fun with this lab. This is one of my favorites.